Okay, everybody, we have made it to graphing trig functions. Well, the only trig functions we're graphing today is sine and cosine. Okay, so starting with the sine function, let's go over some properties which are over on the right-hand side. The domain of the sine function is all real numbers. The range of the sine function is -1 to 1. So it'll never go past those unless there's some type of transformation on the graph. These are the standard properties for sine. Sine is an odd function. We learned that last time. Also, what we learned last time is that sine repeats itself every 2 pi. And then the x-intercepts of sine are multiples of pi, and the y-intercept is 0. Okay, so next is we want to pick the x values based off the unit circle for the sine function. Okay, so picking the correct coordinates for the sine function are all based on its period. It repeats itself every 2 pi. So we want to draw 2 cycles. We're going to draw a negative cycle and a positive cycle. So when I say negative, I mean for my x values, we're going to start with -2 pi and go around the unit circle. So what we're going to hit next is -3 pi over 2, -pi, -pi over 2, and 0, and then use the same coordinates but go positive. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So this will represent 2 cycles of sine. So now plug these into your sine function, and sine at -2 pi, if you look on your unit circle, you're going to get 0. Sine at -3 pi over 2 is going to be -1, but you have a negative weighting on the outside, so you're going to get 1, 0, -1, 0, 1, 0, -1, and 0. These are going to be considered the parent function coordinates for the sine function. So if we ever want to do a transformation, just remember these coordinates. You don't have to remember all of them. I would just say remember the coordinates from 0 to 2 pi, just to do a transformation. Okay. Then let's go ahead and plot our values on the chart below. So go ahead and label our chart. It's going to be -2 pi, -3 pi over 2, pi, pi over 2, and 0, pi over 2, pi, 3 pi over 2, and 2 pi. The highest we go is 1, the lowest we go is -1, as is the range for the sine function. So here is, I'm going to skip 1 and I'm going to make this 1, and I'm going to make this down here -1. Okay, now let's go ahead and plot. So at -2 pi, we're at 0. At -3 pi over 2, we are at 1, 0, -1, 0, 1, 0, -1, and 0. So here is what the sine function looks like. And this goes on infinitely. This is just a graph of 2 cycles. But here's the sine function. The domains are real numbers. It doesn't pass 1 or -1. It has x-intercepts at multiples of pi. So -pi, 2 pi, 0, pi, and 2 pi, all integer multiples of pi. You have an x-intercept, and you have a y-intercept at 0. Okay. And it repeats itself every 2 pi. So if you cut out this section and copied it over, you would have exactly that again. And then it's odd, meaning it reflects across the origin. So this point is, what do we have? Pi over 2 and 1. And if you reflect across the origin, then this point is negative pi over 2, negative 1. That's it. Okay. All right. So that's sine function. Now let's practice some transformations. Okay. So here we are given y equals 3 sine of x. And the directions say graph functions of the form y equals a sine omega x. So remember that fancy little w in there is omega. Okay. So for now, we have y equals 3 sine of x. And if you guys remember transformations, I hope you do, that 3 outside is a vertical transformation. That is a vertical stretch. So if I wrote this out here, this 3 would be a vertical stretch. Meaning, if you take the parent function, its coordinates, and transform them, this means the x values would stay the same because there's no transformations on x, but the y values of the parent function would all get multiplied by 3. That's the vertical stretch. And we would need the parent function coordinates to do so, which I wrote here for you. Now, once again, we don't need all of them. Like I said, we can only use the 1, 0 to 2 pi. So maybe in the future I'll change this, but the more coordinates, the better. So these are the parent function coordinates of sine. We are now going to transform it. So when we transform this, well, once again, it's only a vertical transformation, which affects the y values. So my x values are going to stay exactly the same. Not that. Negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, since it's a vertical stretch of 3, we're going to take all of these y values and just multiply them by 3. 0, negative 3, 0, 3, 0, negative 3, 0. And of course, to check if your transformations are correct, go ahead and plug any of these x values into the function it's giving. So that's a good way to check. So we'd say y equals 3. Let's choose, actually, we'll make it easier. Let's choose pi over 2. Y equals 3 times the sine of pi over 2, which means you'll get y equals 3, and the sine at pi over 2 is 1. So we'll just give y equals 3, which verifies this point. When x is pi over 2, y is 3. Okay. That's how you check. Do you have to check all the time? No, but it is good every once in a while, just to make sure you're on the right track. Okay, so let's go ahead and label our graph. We start at negative pi, so negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now we go up to 3. So there's 3, and there's negative 3. And let's plot. Negative pi, 0, negative pi over 2, we're at negative 3, 0, 3, 0, negative 3, 0. Okay. And of course, if you wanted the whole 2 cycles, well, it's going to be the same on the other side. So over here, you'd be at 3 and then 0. So here is the graph of our transformed sine function. So not much has changed from the last graph. All we did was take the original sine function and just stretch it by a multiple of 3. So instead of bouncing between -1 and 1, we now bounce between -3 and 3. Okay. There it is, transformations. I hope you remember that. Okay. So that's sine. Next is cosine. So properties of cosine. Domain is all real numbers. Just like sine, its range is -1 to 1. Cosine is even, meaning it's symmetric with the y-axis. It'll reflect over the y-axis. Cosine also repeats itself every 2 pi. It has x-intercepts at odd multiples of pi over 2, and the y-intercept is 1. Okay. And then we're going to pick coordinates, the same coordinates that we picked for sine. So let's do that. Just to show 2 revolutions, or 2 cycles. Same thing. -3 pi over 2, -pi, -pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now plug these in to cosine and reference your unit circle. Cosine at 2 pi, -2 pi, which becomes cosine of 2 pi, because cosine's even, becomes 1, and then 0, -1, 0, 1, 0, -1, 0, 1. Definitely double check these on your unit circle. Okay, and there's our cosine function. Where can I fit? There. Okay, and now label your graph. -2 pi, -3 pi over 2, pi, -pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then I'll make that one, make that -1, and plot. -2 pi, we're at 1, 0, -1, 0, 1, 0, -1, 0, 1. And then graph. Well, not straight up. Whoops, dang it. So this would be something like this. Okay, so here is the cosine function. Just like it says, it goes on infinitely. Domain's all real numbers. The range is -1 to 1. It's stuck between -1 to 1. Cosine's even, meaning it reflects across the y-axis. To prove that, you would have this point at pi over 2 and 0. If you reflect it over, you have -pi over 2 and 0. Same thing with these 2 points. They reflect over the y-axis. You have x-intercepts at every pi over 2. So we have an x-intercept at 3 pi over 2, pi over 2, pi over 2, 3 pi over 2. These are odd multiples of pi over 2. And our y-intercept is 1. Okay, that is cosine. Now let's transform it. These are also, before we move on, those are the parent function coordinates for cosine. Okay. So we are given y equals 2 cosine 3x. So before we begin, let's list what's going on. First off, just like on the last problem, the 2, I'll write it a different way, is a vertical stretch, which means you'll take the parent function's y values and stretch them by a multiple of 2. Then the 3 happens to be 3 inside is a horizontal compression. Which means that, remember, for any type of horizontal transformation, you always think opposite. So there's a horizontal compression by 1/3. Whatever number is in front of that x, you will always multiply by the reciprocal. So if it's 3, 1/3. If it's 5, 1/5. If it's 1/2, multiply by 2. Always the reciprocal. Vertical stretches, straightforward. This 2 out front means we multiply all the y values by 2. No opposite, no reciprocal. Whatever is inside is always think opposite. So, okay. Well, I have the parent function, I have the parent function coordinates over here. So it makes it easy for us to transform. So the first thing we're going to do is the horizontal transformation by compressing all the x values by 1/3. And I'll keep it in green, which means you multiply all these x values by 1/3. Negative pi thirds, negative pi over 6, 0, and then pi over 6, pi thirds, pi over 2, and 2 pi over 3. Okay, so that one's easy. And now we multiply all the y values by 2. So negative 2, 0, 2, 0, negative 2, 0, 2. Okay. And now let's go ahead and label our graph. Negative pi over 3, negative pi over 6, 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, and then 2, and negative 2. Okay. And then plot our values. At negative pi over 3, we're at negative 2. At pi over 6, 0, 2, 0, negative 2, 0, and then 2. Okay, and then you can just repeat this over here. You'd be at 0, and then 2. So here is the graph of the vertically stretched and horizontally compressed cosine function. That's it. So to do transformations, you must remember what transformations are going on the function. So if you don't know, I definitely recommend refreshing on it. Okay, so that's transformations. And that's sine and cosine. Now we get into something called amplitude and the period of the sinusoidal functions. So we are given the trig function sine and cosine, and we want to know what's their amplitude, which means how high does the function go and how low does the function go, and what's the period? When will the function repeat itself? So if there are transformations on the function, then of course the amplitude will change and the period will change. So as you see here, amplitude is always given by the absolute value of A. So whatever number's in front is considered the amplitude. The period's a little different. So you have omega inside. And to find the period of our functions, you're going to take 2 pi and divide it by the absolute value of omega. And whatever you get will tell us when that function repeats itself. What is the cycle of that transformed trig function? Okay, so let's try it out on the first one. Y equals 3 sine of x. The amplitude is the number in front, so that's just 3. Easy. But then the period is going to put 2 pi over that number inside 4, which means since this function is transformed, this function of 3 sine 4x is going to repeat itself every pi over 2 instead of 2 pi, only because there's a transformation inside. Okay, that's it. Not bad, right? Next, find the amplitude of 6 sine pi x. So, amplitude is easy. Oops, different color. Actually, I won't. We're good. Amplitude is 6. Period is 2 pi over the inside transformation of pi. So you put it 2 pi over pi. Hey, and this function will repeat itself every 2 units. Okay. Last one. Amplitude of 9/5 cosine negative 3 pi over 2x. You get amp at 9/5. Period 2 pi over, now since this is negative, it's always over the absolute value, so we just put it over the positive number. And 2 pi over 3 pi over 2 must be fixed by multiplying by the reciprocal of 3 pi over 2, and your pi's will cancel, and you'll get 4/3, which means this function will repeat itself every 4/3 units. So that's it. That's what amplitude and period are. Amplitude is how high it goes, and period is when will the function repeat itself. How will it repeat itself? So I guess to make more sense of that is if we looked at this function that we graphed already, the transformation, and your amplitude would be 2, because it goes up 2, down 2. But then your period would be 2 pi over the number inside there, 3. So 2 pi over 3. So this means that this function would repeat itself every 2 pi over 3 units, as you see there. So that's what we're saying. So that's what a horizontal transformation will do to a function. It'll change its cycle. So this one repeats itself every 2 pi over 3. And even over here, this would be negative 2 pi over 3. So that's all. Okay. Now, another way to graph trig functions if you absolutely hate transformations and love doing work step by step by step. Okay, it's called key points. And our goal is to make 5 key points. So let's get started. The first thing we want to do is determine the amplitude and the period. So fair enough, given 3 sine 4x, the amp is 3. And the period puts 2 pi over 4. So pi over 2. So this function will repeat itself every pi over 2 units. Now, our goal is to create 5 key points, and to do so, we have to create 4 sub-intervals. 4 sub-intervals. And we start at 0, and we'll end at our period of pi over 2. So the main interval is 0 to pi over 2. That's the main interval, because that's when it's going to repeat itself, every pi over 2 units. Our goal is to split this interval into 4 sub-intervals. So in order to do that, we need to know what the length of each sub-interval is. And in order to do that, well, there's a little formula for that. So length of sub-interval. Since we're making 4, the formula for this is to take our period, which is 2 pi over omega, and divide it by 4. That's the formula. Take the period that we found and divide it by 4. This means you'd have pi over 2 over 4, which would become pi over 8. This is the length of each subinterval. So I'll show you how to start it and how to use that length. So for the first subinterval, we start at 0 and we add the length, pi over 8. That's where we end. That's the first subinterval. The second subinterval, we start where we left off, at pi over 8. And we add another pi over 8. So what does that look like? Gives me 2 pi over 8, which gives me pi over 4. So that's the second subinterval. The third subinterval, we start at pi over 8, pi over 4, and you add another pi over 8. So what does that look like? Pi over 4 plus pi over 8, get a common denominator of 8, 2 pi over 8 plus pi over 8 gives me 3 pi over 8. So that's where we end, 3 pi over 8. Now, the fourth and final subinterval, we start at 3 pi over 8, and we add another pi over 8. What does that look like? Let's find out. You get 4 pi over 8, which becomes pi over 2. And that's where we end. Man, transformations, we would have been done a long time ago, trust me. Okay. Now, how do you know if you did these intervals right? The only way to know if you did these intervals right is if your endpoint on the fourth interval matches the endpoint on your main interval. So the endpoint of the fourth subinterval has to match the endpoint of your main interval. Okay, so now we get to make our 5 key points, meaning we're going to use the x values we just created. Oh yeah, if you did not know, all of these are x values that we are now going to plug in for x into the function to get our y values. Yes, lots of work. So we're going to start first with 0. So to get our 5 key points, we start with 0, and then we go to pi over 8. And then we choose, where's my second one? Pi over 4. And let's start with these 3, because then I don't want to mix everything up. So what we're going to do is, once again, take these x values and plug them into the function above. So you should have y equals 3 times the sine of 4 times 0. Y equals 3 times the sine of 4 times pi over 8. And y equals 3 times the sine of 4 times pi over 4. Okay, and if you plug those in your calculator, make sure your calculator is in radians. And actually, I'm going to show you a lovely calculator trick just to help make this process a lot faster. So let me see. Do I have my calculator up? I do not. Let's see. I'll use the TI-84. Yep. Oh, broken. Okay. Can't use the TI-84. What else do we have? Get out of here. TI Smart View. We'll use the regular blue calculator. That's broken too. Okay. Well, we are headed to desmos.com then. My Google Chrome doesn't work on this computer. I have no idea why. There it is. We go to Desmos, and now this is actually going to be a lot better. So we go graphing calculator. And now, how do I make sure this is in radians? I think I hit that tool. Down here, we are in radians. Okay. Now I'm going to type in this exact function. Y equals 3 sine 4x. Okay. So you see it graphs for you already, which is great. But we're more worried about the values. How do we find the values that we're plugging in down below over here? So what you're going to do on Desmos is hit this little gear icon. And there's a little table option. Hit the table option. Okay. And now let's type in our values. I have 0, which will give me 0. So I'll write that over here. 0. And then I have pi over 8. So I'll type in pi over 8 over here. Pi over 8. And we get 3. Nice numbers, look at that. 3. Then you type in pi over 4. And you get 0. Look at that. Now we have the last 2 key points to plug in, which is 3 pi over 8 and pi over 2. So I just do that over here. 3 pi over 8. You get -3. And then last one is pi over 2. Pi over 2. And there it is. These are considered our 5 key points. So let me write them down over here. So last was y equals 3 sine times 4 times 3 pi over 8, which gave me -3. And y equals 3 sine times 4 times pi over 2, which gives me 0. Okay, now you have our 5 key points. So I'm going to go back to the notes. And let me just squeeze these in here. This was at x equals 3 pi over 8. And this was at x equals pi over 2. Okay, and now you have your 5 key points. So we have, if you want to list your points, we have 0, 0, pi over 8 and 3, pi over 4 and 0, 3 pi over 8, and -3, and then last would be pi over 2 and 0. So we have just found our 5 key points to graph, and now let's label our graph appropriately. Here's 0, here's pi over 8, Here's pi over 4. Here's 3 pi over 8. And here's pi over 2. And if it wants you to do 2 cycles, well then, just make everything negative in descending order. Negative pi over 2, negative 3 pi over 8, negative pi over 4, and negative pi over 8. And then the highest we go is 3, the lowest we go is negative 3. So 3, negative 3. Okay, and now let's graph. 0, 0. At pi over 8, we're at 3, 0, negative 3, 0. And then you can repeat it, just flip everything over the origin. You'd be at negative 3, 0, 3, 0. And here is the sine function, the graph, the transformed sine function using key points. And that was key points. So now you as a student make the decision. If you like key points, use key points. If you like transformations, use transformations. Only choose one. Do not choose both, because come test day, you're like, oh, I like transformations, but I like key points. No, stick to one method and one method only. Do not switch back and forth. Transformations gets it done like that. Key points is step by step by step and fail safe. Maybe even fail proof, unless you mess up a sign or something. But that's key points. If we did transformations, we would have been done with this video a long time ago. Okay. So now you as a student choose what you want. I'm going to do this next graph by transformations, because I like transformations a lot. Okay. If you want to see key points, definitely ask in class to see key points for this one. Okay. So I'm going to do this by transformations. So first thing I need are the parent function's coordinates for the original function cosine. So I'll have x and y equals cosine x, and I'm only going to choose the positive revolution numbers. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So these are the parent function coordinates. 1, 0, negative 1, 0, 1. And now we are going to, new color, transform. And to know the transformations, well, let's write the function down below. All right, label our transformations. The negative 4, actually, just the negative is a reflection over the x-axis. The 4 is a vertical stretch. The pi is a horizontal compression by, and remember, anything inside the function is considered a horizontal transformation, and you always think opposite. So if that's pi, you're going to automatically multiply by 1 over pi. And then the negative 2 is a vertical shift down. So here's what we're going to do. We're going to take the function, flip it over the x-axis, stretch it by 4, shift it down 2, and compress it all at the same time. That's our transformation. So when you set up our XY chart for this transformation, we're going to multiply all the x values by 1 over pi. And then we're going to multiply all the y values by -4 and then subtract 2. So we'll start with the x values over here, times them by 1/pi, and you'll get 0, 1/2, 1, 3/2, and 2. That's when you multiply all of the x values by 1/pi. All the pi's will essentially just cancel. Okay, and then we now multiply all the y values by -4 and subtract 2. So -4 times 1 is -4 minus 2 gives me -6. -4 times 0, 0 minus 2, -2. -4 times -1 is 4, 4 minus 2 gives me 2. And then 0, you get -2. And then the last one, -4 minus 2 gives me -6. There it is. Transformed, no key points. Again, if you like key points, I can show you in class. Okay, so now all we have to do is graph it. We're using, of course, these coordinates. So 0, 1/2, 1, 3/2, and 2. And then just reverse it for the second cycle. And then the highest we go is 2, and the lowest we go is -6. So we're gonna have to do these by 2s. So this will be 2, and then 2, 4, 6, down here will be -6. Okay, now let's plot. 0, -6, 1/2, and -2, which is right there. 1 and 2, 3/2 and -2, and 2 and -6. And for the second cycle, just flip it across the y-axis since cosine's even. So we'll be back at 2, -2, 2, -2, -6. And here's what we look like. And there it is. There is the transform cosine function that we flipped over the x-axis, stretched it by 4, shifted it down 2, and compressed it by 1/pi units. Beautiful, I know. Transformations is better than key points, but you decide which one you want. Like I said, key points isn't bad. It's just step by step by step. This one, we didn't even have to whip out a calculator for. So once again, you decide which you like better. Okay. No more graphing. The last page. This time we're given a graph, and we have to find out what function it is. So what function does it most look like? And let's see. First off, the first clue given is amplitude, and the second clue given is period. After that, we just have to match it to a function we believe it belongs to. Okay, so the first thing given is amplitude. We go up 3, down 3. So that's given. Amplitude is 3. Next is the period. It looks like this function repeats itself every 1 unit. So remember, period is given by 2 pi over omega. And what they're telling us is that the period is equal to 1. So our goal is to solve for actual omega. And the reason we're solving for omega is because, remember, we have 2 choices. Y equals a sine omega x, or y equals, not sine, sorry. y equals a cosine omega x. So we need to know which one it belongs to, so we have to find the value of omega. So easy enough to find this, you just multiply omega to the right side, and you'll get 2 pi equals omega. So we have amplitude and we have omega. Now we need to know is this a cosine or sine function? And if you think about it, let's look at this value. Up here, there is a y-intercept of 3. So if you relate that to the beginning functions, let's go all the way back to the original sine function. Sine always runs through 0, 0. Cosine always runs through 1, 0. So if we look at this function again down below and make an assumption, since we run through 3, 0, this has to be closely related to the cosine function. Only because cosine has a y-intercept at 1, 0, and if it's at 3, 0, then we must relate this to cosine. Now, to be saying that's the only answer would be incorrect. This can have multiple answers, probably infinite answers, but today we're keeping it simple because we haven't learned about phase shifts, meaning shifts to the right or shifts to the left. We only know about shifts up or down, compressions or stretches, right? So keeping this really simple, our answer is going to be, so this function is going to be y equals 3 cosine 2 pi x. There it is. That's it. That's keeping it really simple. Maybe I need to make that fit on there, right? There you go. Perfect. Okay, that's it. Keeping it really simple. Now, very last one. Write the equation of a sine function with amplitude 2 and period 7. And the period is 7. Okay. So once again, they're giving us the pieces. Amplitude is 2, and the period they're saying is 7. So I think what we have to do again is say 2 pi over omega equals 7. And this means that if you solve for omega, you get 2 pi equals 7 times omega. And to solve for omega, you divide by 7. And we get 2 pi over 7 equals omega. And this said write a sine function. So we're looking at making a sine omega x. So our answer is going to be y equals 2 sine 2 pi over 7 x. Okay. Or, since amplitude is always given by the absolute value, we actually have 2 answers here. It can also be y equals negative 2 sine of 2 pi over 7 x. And there's our 2 answers. Okay. That is graphing sine and cosine using transformations or key points. Remember, you choose one. But that's it. Nothing crazy. See you at the next one.